Thermodynamic properties. So discussions points are compressibility factor, mole weight, internal energy, enthalpy energy, specific heat capacity, entropy, kinetic energy, compressor work head. So we'll discuss about all these points. Compressibility factor, it takes care of volume change due to change in the pressure and or temperature. Normally it increases with increase of temperature at constant pressure and vice versa, and it decreases with increase of pressure at constant temperature and vice versa. It is used for real gas application. Compressibility factor is related to gas critical pressure, critical temperature, and eccentric factor, and it is calculated based on gas composition, operating pressure, and operating temperature. Now, compressibility factor can be understood based on the density of the real gas and ideal gas. We know density of the real gas is P into M upon ZRT, and density of the ideal gas is P into M upon RT. Then there is a relationship of real gas density and ideal gas density, which is expressed based on the above two equations. So density of real gas is equal to 1 by Z into density of the ideal gas. So we can write density of the real gas upon density of the ideal gas is equal to 1 upon Z. Z is a compressibility factor. So we can say density ratio of real gas and ideal gas is inversely proportional to compressibility factor. That means this is if case number 1, when Z is greater than 1, that means compressibility factor is greater than 1, the density of real gas is less than density of ideal gas. Case number 2, when Z is equal to 1, then density of real gas is equal to density of ideal gas. And case number 3, when Z is less than 1, density of the real gas is greater than density of ideal gas. Mole weight. Mole weight is defined as a mass per unit mole. It is denoted as kg per kilomole. It represents condition of gas, whether it is heavy or lighter. More the mole weight, more the heavier gas is. Mole weight of hydrocarbon mixture is calculated based on the gas composition. In case of air application, mole weight of moist air increases in a higher stage of compressor as condensation of water vapor occurs in each stage. Now, internal energy. Internal energy is defined as a product of a specific heat capacity at constant volume and change in temperature. If the process between 1 and 2 is compression, then temperature T2 is more than T1, and so change in internal energy is positive. Similarly, for the process expansion, then change in the internal energy would be negative as T2 is lesser than T1. If T1, T2 are two thermodynamic points and average heat capacity at constant volume is a CV, then change in internal energy between these 2 points is expressed as internal energy change, that is U, is equal to CV into bracket start T2 minus T1. Enthalpy energy. Enthalpy energy is associated with pressure and temperature of the gas. Enthalpy energy is equal to summation of internal energy and the pressure energy or potential energy. Internal energy represents energy associated with the temperature, and pressure energy represents energy associated with the pressure. Enthalpy will be high if pressure and temperature of gas are higher. So enthalpy change H is equal to internal energy plus pressure energy or potential energy. So U is equal to, sorry, H is equal to U plus P into V. Enthalpy energy is also defined in the most popular form as a product of a specific heat capacity at constant pressure and change in temperature. So if T1 and T2 are two thermodynamic points and average a specific heat capacity at constant pressure is Cp, then change in enthalpy energy between these 2 points is expressed as H is equal to Cp into bracket start T2 minus T1 bracket close. A specific heat capacity. Two types of a specific heat capacity are defined. One at constant pressure and another is a constant volume. Constant a specific at heat capacity at constant pressure is the heat energy per unit mass per unit absolute temperature. Similarly, a specific heat at constant volume is the heat energy per unit mass per unit volume per unit absolute temperature. A specific heat capacity ratio is defined as the ratio of a specific heat capacity at constant pressure and a specific heat capacity at constant volume. So a specific heat capacity at constant pressure is Cp and a specific heat at constant volume is Cv. So a specific heat capacity ratio K is equal to Cp by Cv. Entropy. Entropy is defined as the ratio of heat energy and temperature. Heat energy and temperature and expressed as Q by T, where Q is the heat transfer and T is the temperature. And also change in entropy delta S is equal to delta Q upon T. That means entropy remains constant if heat is not transferred for any process. In compressor and process turbine, heat is not transferred and so entropy remains constant. The process is called the isentropic process or adiabatic process. However, in case of heat exchanger, where one gas takes heat from another gas, heat is transferred and so there is a change in entropy. The gas which takes heat will gain in entropy and gas which releases heat will have decrease in entropy. Entropy provides information that the process is ideal or not. If there is no change in entropy, the process is ideal and process called the isentropic process. If there is a change in entropy, that indicates the process is not ideal and so not isentropic process. Kinetic energy. The gas having velocity has kinetic energy. The higher the velocity, higher the kinetic energy. Kinetic energy converted into enthalpy in diffuser by decreasing the velocity. Similarly, enthalpy is converted into the kinetic energy in nozzle. So, change in enthalpy is equal to change in kinetic energy, which is expressed as delta H is equal to delta K is equal to half of bracket start V2 square minus V1 square, where V1, V2 are velocity at 2 points. Work head, compressor work head. Compressor does work in compressing gas from low pressures to high pressure. Head is defined as work per unit mass. Work head is expressed as delta H is equal to V into delta P, where delta H is the head rise, V is a specific volume, and delta P change in pressure. If total head rise is needed, then integration of above equation to be done after replacing a specific volume as per compression process. Normally, three types of compression process occurs in compressor. These are isothermal compression process, isentropic compression process, and polytropic compression process. In isothermal process, temperature remain constant, and in isentropic process, entropy remains constant. Polytropic process is summation of isentropic process of very small stage of compressor. So three types of head rise are used in compressor. These are isothermal head rise, isentropic head rise, and polytropic head rise. However, only isentropic and polytropic head rise used in compressor industries. So now you have understood about some properties like what is compressibility factor, internal energy, enthalpy energy, entropy, and compressor work head rise, molecular weight, etc. So hope you like this. Thank you for watching.